Hello, good morning, students. Today we will study from biomolecules, structure and properties of glucose. So, glucose has aldohexose structure. Aldohexose means containing aldehyde functional group and 6 carbon containing sugar called as a aldohexose sugar. In other words, glucose molecule contain aldehydic group. That aldehydic group is also called as a formyl group, and the remaining 5 carbon atom contains one hydroxyl group each, and 6 carbon atom in glucose forms straight chain. This aldohexose structure of glucose, this is explained on the basis of following chemical properties. So first chemical property is the molecular formula of glucose was found to be C6H12O6 on the basis of elemental composition and colligative properties. In chapter number 1, in chapter number 2, that is solution and colligative properties, we had studied how to determine molecular formula of different compounds. So on the basis of colligative properties, the molecular formula of glucose that is observed, it is C6H12O6. So this is the first property that explains the molecular formula of glucose. Then the 6 carbon atoms in glucose molecule, it form a straight chain. This was inferred from the following observations. The glucose give N-hexane. It is an alkane. It is a straight chain alkane containing 6 carbon atom, that is N-hexane. So glucose give N-hexane on prolonged heating with hydroiodic acid, and the reaction is, it is a CHO, CHOH 4 times CH2OH. This is straight chain structural formula of glucose. Total contains 6 carbon atoms. First is aldehyde functional group. First is aldehyde functional group, and this aldehyde functional group contains this CHO, then CHOH 4 times, secondary alcoholic group 4 times, and CH2OH is a primary alcoholic group. So this is structural formula of glucose. When it is heated long time with hydroiodic acid, then this glucose is converted into N-hexane. N-hexane is a straight chain alkane containing 6 carbon atoms. So this glucose is converted into N-hexane by prolonged heating, and this explains the 6 carbon atoms in glucose. They are in straight chain. Third property that explains the structure of glucose, that glucose molecule contain one carbonyl group, and this is observed from the oxime test, that is reaction with hydroxylamine that gives the cyanohydrin on reaction with hydrogen cyanide. So these two reactions that explains the glucose contain this aldehyde functional group. So one of the tests is, this is the structure of glucose. In the structure of glucose, there is a CHO, that is aldehyde functional group, then CHOH 4 times, secondary alcoholic functional group 4 times, and CH2OH is a primary alcoholic group. So there are total 6 carbon atom in a straight chain, in glucose molecule when it is treated with hydroxylamine. Hydroxylamine is NH2OH. Then this oxygen atom from the aldehyde group that react with two hydrogens of hydroxylamine, and it gives H2O as a side product, and the remaining part is here the CH. This is a part of the group from aldehyde group from glucose, and double bond NOH. This is the remaining part of hydroxylamine. So this compound obtained, that is called as a oxime of glucose. It is obtained by the reaction of glucose with hydroxylamine. So this test confirms glucose contains aldehyde functional group. This aldehyde functional group present in glucose can be confirmed by testing with hydrogen cyanide. Hydrogen cyanide is a HCN. When it is added in glucose molecule, then in the aldehyde group, here O get bonded with hydrogen and becomes OH group, and cyanide group get bonded to this CH group. So here the cyanohydrin of glucose is obtained having structural formula CHOHCN CHOH 4 times CH2OH. So this is cyanohydrin of glucose. Then the next property of glucose which explains the structure of glucose is fourth property. The carbonyl group in glucose is in the form of aldehyde, and it is confirmed, it is observed, or it is informed on the basis of oxidizing property of glucose. This glucose molecule on oxidation with bromine water, then it is converted into gluconic acid, means the CHO aldehyde functional group is converted into carboxyl group. So here bromine water is a mild oxidizing agent, and the reaction is the CHO CHOH 4 times CH2OH. This is structural formula of glucose. When it is treated with bromine water, then bromine water give nascent oxygen, and which oxidizes this aldehyde functional group of glucose into COOH, that is a carboxylic acid functional group. This is mild oxidation of glucose. Glucose is converted into gluconic acid. Then the next property of glucose which explains about the hydroxyl groups present in the glucose. Glucose contains 5 hydroxyl groups. One of the hydroxyl group is a primary, and remaining hydroxyl groups are secondary. So when glucose is treated with acetic anhydride, then glucose form glucose pentaacetate, that is hydroxyl group are converted into acetate group. So glucose is a stable compound. It was further informed that the 5 hydroxyl groups are bonded to 5 different carbon atoms in the glucose molecule. They are not bonded with one and the same carbon atom in the glucose molecule. They are bonded with 5 different carbon atoms, and this can be tested with this acetic anhydride test called as a acetylation of glucose. In the acetylation reaction, this glucose is treated with acetic anhydride. Here acetic anhydride is CH3 C double bond O 2 times O, that is acetic anhydride. When this acetic anhydride is treated with Glucose, the structure of glucose is CHO, aldehyde functional group, then CHOH 4 times, secondary alcoholic 4 OH groups, and CH2OH is a primary alcoholic group in glucose. When treated with acetic anhydride, then this secondary alcoholic group, they are converted into acetyl group, that is CH3CO group. Similarly, primary alcoholic group, that is also get bonded with acetyl group, and we get here product is glucose pentaacetate containing 5 acetate groups, plus side product in this reaction is CH3COOH, that is acetic acid. Here, for balancing this equation, 5 molecules of acetic anhydride are required so that we get side product as acetic acid, that is again 5 molecules. So this confirms there are 5 OH groups present in glucose molecule, and therefore glucose forms glucose pentaacetate. Then glucose contains one primary alcoholic group. Glucose molecule contains one primary alcoholic group. Primary alcoholic group is CH2OH, and this is tested with nitric acid, that is oxidation reaction. This is a glucose molecule, that is CHO, CHOH 4 times, CH2OH. Here CH2OH is a primary alcoholic group. When treated with nitric acid, then nitric acid is a strong oxidizing agent. It is a dilute nitric acid. It oxidizes both aldehyde group and this primary alcoholic group into carboxylic group. So we get here dicarboxylic acid containing compound, and secondary alcoholic group remains the same. This is called as a saccharic acid. So saccharic acid having formula COOH, CHOH 4 times, COOH. This is saccharic acid. In the previous test, we had studied that glucose can be oxidized into gluconic acid. So only aldehyde group in the glucose that is oxidized into carboxylic group. So here it is called as a gluconic acid. This gluconic acid, when further treated with dilute nitric acid, then it oxidizes primary alcoholic group into carboxylic group, and we get saccharic acid as a product. So this reaction explains the presence of primary alcoholic group in glucose. So these 6 chemical properties that explains this functional group present in the glucose. So we had studied that the glucose contains one aldehyde functional group, 4 secondary alcoholic functional groups, and one primary alcoholic functional group. These are tested with these different reagents. Thank you.